so hopefully you have done 1 through 14 on your homework, and we are moving on to day 2 of this, where I'm going to do a little bit more challenging problems. Let's jump in. I kind of wanted to talk a little bit about when you have these fractions that you're starting with and some options that you have. And there's not necessarily a right way. It's just nice to recognize, oh, sometimes this might be come to you in a different way, in a different time. A different way might come to you, and sometimes there's a better way. Just you have options. All right, that's what it boils down to. You got options. Okay, so when I see this right here, there's actually 3 ways I might deal with this problem. Option 1, separate the big fraction into 2 smaller fractions. All right, you can do that because ultimately you're doing 1 divided by cosine x and sine divided by cosine x. So let's look and see. If I were to separate this out to 2 separate fractions, it would look like this. 1 over cosine x plus sine x over cosine x equals your secant x plus tangent x. And then, well, 1 over cosine is secant x. And sine over cosine is tangent x. And we've got it verified right there. Now, it does help me if you do things like this. It helps me kind of figure out from step to step what your thinking process is. So any of those little helpful hints, always appreciated. Let's take a look at this problem with a different method. What if, instead of working on the left side, when you saw this, you thought, well, let's go sines and cosines on this, and you left the left side alone because it already has sines and cosines. And on the right side, you changed this to a 1 over cosine x, and this is a sine x over a cosine x. Oh, look, it's a common denominator, so you'll be able to combine it together, and boom, you have it verified. You actually could kind of merge option 1 and option 2 together. You could work on the left side and the right side at the same time and end up verifying it probably shorter, right? All right, I've got one more option you might consider. And before I talk about the option this third option, I want to mention an option that's not there for you. You cannot take and multiply both sides by cosine x. Remember, we try to work just on the left side, just on the right side. Don't start moving things from left to right on there. So don't try to get rid of the fraction that way. Another way to work through it to get rid of that fraction instead is pop this cosine x to the top. And remember how you can pop those reciprocal functions? If I pop it up, it'll call it a secant x. All right. Again, helps me to show me, oh, I'm just going to take that up and I'm going to write secant x 1 plus sine x equals secant x plus tangent x. Now, if I'm trying to get these to match, I don't want to have the parentheses there, so now I'm going to distribute. I'm going to write secant x plus secant x sine x. And then I am going to write secant x plus, now I'm going to bump that secant x back to the denominator here and make it look like that. And then I could go one more, but I do want you to recognize, I mean, what we tend to do sometimes is just get in our groove and we're just working with the left side, working the left side, and it gets to be a very long proof. It doesn't have to be if you're willing to work with both sides. So sometimes you don't necessarily see that. And that's why I sort of kind of worked with the left side there. And then I kind of held off on the right side. And then when I saw where I landed, now I'm just going to change this to a sine over a cosine. And now they match. And I don't care that they don't look clean. It just saved me a step from going down to tangent on that. So 3 options of ways to do the same problem. So when you're doing a problem one way and your neighbor's doing it a different way, that doesn't mean somebody's wrong. It just means maybe you had a different idea of how to approach it. Totally fine. All of those were fine methods. Let's try a problem here where it is a ton of fractions and they are not pretty, and that is okay. All right, we can work through fractions. We're big kids. All right, so when you are adding fractions, you got to get a common denominator. All right, and my common denominator is really just this 1 plus sine x and this cosine x. So there's no real clean way of doing it other than just taking this side times cosine x and this side times 1 plus sine x. All right, this one might take us a little bit more, so maybe write little here. All right, I'm going to have cosine squared x plus, and over here, I'm going to have to FOIL that together. So it's going to be plus, first gets me a 1, outer is a sine x. Oh, outer is a sine x, but so is inner. So that's going to be a plus 2 sine x. And last is a sine squared x. And this is all over my common denominator. I usually want to leave that separate because there might be some reducing, so don't feel like you're going to try to distribute down here. Leave these separate. And then the only thing I'm thinking on this other side is that it's a secant, whereas the left side is all sines and cosines. So I'm kind of inclined to bump that secant to the denominator and call it 2 over cosine x. All right, now what? I got a mess. Well, it's that whole thing where you have got to be looking for something to pop out at you, and you've got to know those identities well enough that it pops out at you. This right here is what I noticed. I have a cosine x squared and a 1, but it's a plus, and that is not a thing. But I do have a cosine squared x and a sine squared x. So wouldn't those two combine to equal 1? All right, so I'm going to do a little cheat here. I'm going to show that, look, this and this gets me a 1. If you can do that, then I would probably go ahead and accept you taking that 1 plus the other 1 and calling it a 2 plus 2 sine x. That's what's left there. Over a cosine x, 1 plus sine x. Okay, nothing really to do on this other side yet. I just must have a lot of reducing to happen on the left. And I kind of hinted there earlier that I'm going to want something to cancel out in that denominator. And I can't really just cancel out sine x because of the addition is tying this all together. But what I see that I could do up here is I could factor a 2 out of that. And when I factor that 2 out, I get a 1 plus sine x. Oh, this is going to look pretty. It's going to work. It's going to work. Still think I'm going to leave the right side alone because those 1 plus sine x's are going to cancel. And oops, I forgot my x. Minus 1/2. And we match. All right, so when you have fractions, nice or not, and you're trying to add them, you're going to be doing common denominator stuff. All right, I got one more for us. It really is kind of the same deal. My hint is that you need to be working both sides. I kind of did that on the previous one anyway, but maybe this one's a little bit more complex. And it's not a bad idea to practice this one more time. Ugly denominators, as much as we want to think there's something similar about these, there just really isn't. It's like if you had an x plus 4 and an x minus 4. They are not the same thing. You got to multiply each side by the other. So I'm going to do a 1 minus cosine x on both sides and 1 plus cosine x. Oh, I guess it's not an x, it's a theta. I know you're going to say, can I just write it as an x? Well, I don't know. Is x the same as a y? Not really. You're supposed to use the same variable that's given. Okay, here's what I end up with. I have a 1 plus cosine theta times a 1 minus cosine theta. On the top, I'm just multiplying by 1, so that's going to play out nice. Plus there, cosine theta. All right, I don't know. What do you do on the right side? What are you thinking? I'm kind of thinking factoring out that 2. What do you think? Let's do it. Hmm. Okay. I'm stalling and making you think. Are you thinking or are you waiting for me? I see that this cosine and this cosine cancel. So I'm going to be left with a 2 in my numerator. Now I like having a 2 because there's a 2 on the right side also. But remember I said don't be multiplying this stuff together because you're hoping something's going to cancel. But I don't have anything left in the numerator that's going to cancel. So now I'm going to go against what I just told you. I think I am going to multiply these. And actually, this is the whole reason that we're doing this problem is I want you to notice what happens with this. These are conjugates. They're identical except one's a plus and one's a minus. Do you remember what happens when you multiply conjugates? I'm going to multiply first. I get a 1. Look at your outer and your inner. It's a negative cosine theta and a positive cosine theta. Those are going to cancel. Outer and inner cancel. And all I get left is a minus cosine theta, cosine squared theta. All right. And that, ladies and gentlemen, is a Pythagorean identity that has been rearranged. What is 1 minus cosecant squared theta? That is a sine squared theta. So that process right there, this is kind of handy for you to know. If you see conjugates, we typically will multiply them together because you're going to be looking at a Pythagorean identity when you do. And then it's going to get you down to a nice single term. But we don't only work this way through it, sometimes we work the other way through it. If we're trying to break this down, we'll switch it out to a Pythagorean identity. This is a difference of squares that factors to this. So definitely something you want to be kind of aware of. It pops up quite a lot. Let's look at the other side. Over here, did you happen to notice that that 1 plus cotangent squared is a Pythagorean identity? It is. So I end up with 2 cosecant squared theta. And a cosecant squared theta can bump to the denominator as a sine squared theta. So I did thorough work on both sides there, sometimes pausing on the right to see how this played out so that I would know how to move forward with this. But I kind of knew right away when I saw that I was going to be switching that out. Okay, well, give the rest of your homework a shot. Again, hopefully you finished through 14. And so now we're finishing it all up. Good luck. Have fun.